It was designed to disappear, a jet that can slip into enemy airspace while radar screens show nothing at all. For years, that invisibility has made the F-22 America's most feared fighter. But radar is getting smarter. Countries are building new systems, pushing harder than ever to spot the jets they once couldn't touch. So the big question is, can the F-22 still stay hidden, or is its cover finally being blown? Today, we'll explore how radar really sees or fails to see the world's stealthiest fighter jet. To understand how the F-22 can avoid detection and why it's so hard to track, we first need to look at the basics of radar and stealth, the two sides of this high-tech cat-and-mouse game. Ever wonder why some jets seem invisible on radar? It all comes down to radar and stealth. At its core, radar is simple. It sends out radio waves that bounce off objects and return to the receiver. The stronger the bounce, the easier it is to spot something. Size, material, angle, and distance all matter. A big, shiny aircraft reflects a lot, while something small or oddly shaped barely leaves a trace. Think of it like shouting in a cave. The louder the echo, the easier it is to know what's in the room. But not all radars are the same. Different frequency bands like X-band and L-band have their own strengths. Higher frequencies give better accuracy but shorter range. Low frequencies can pick up stealthier planes from farther away, though less precisely. Now, stealth is basically the other side of the radar game. The goal? Don't reflect enough energy back to be seen clearly. That's measured by radar cross-section, or RCS essentially, how big a jet appears on a radar screen. With the right stealth, a fighter can look like a tiny bird instead of a massive truck. Stealth isn't magic, it's a combination of tricks. Shapes deflect radar waves, special coatings soak up signals, and even heat is managed to hide from infrared sensors. Of course, there are trade-offs. Speed, cost, and maintenance all take a hit. And stealth works better against some radars than others, which is why the cat-and-mouse game never ends. Understanding these basics sets the stage to see exactly how the F-22 uses stealth to slip past even the most advanced detection systems. So how does the F-22 actually stay off most radar screens? The secret lies in its design. Every curve, angle, and material was chosen to make the jet harder to detect. First, shaping is key. The F-22's sharp, angled surfaces scatter radar waves away instead of reflecting them back. Think of it like bouncing light off a mirror at just the right angle so it never hits your eyes. Next, nothing sticks out. Missiles and fuel tanks aren't slung under the wings like older fighters. They're stored inside internal bays. It's like keeping all your shiny objects tucked safely in a drawer. Nothing to give you away. Then there are the materials. The jet's skin is coated with radar-absorbent material, RAM, that soaks up signals rather than bouncing them back. Imagine throwing a ball at a wall. Normally it bounces back. RAM is like a soft sponge. It soaks up most of the energy, so very little returns to the radar. Even heat is carefully managed. Engine nozzles and exhaust systems minimize infrared signatures, making it harder for heat-seeking sensors to spot the plane. Composite materials and advanced alloys further reduce radar reflection, without adding unnecessary weight. The result? On many radar screens, the F-22 doesn't look like a fighter jet at all, more like a tiny, harmless object instead of a full-sized aircraft. Of course, this level of stealth comes with trade-offs. Every coating, every angled surface, every internal bay adds complexity, cost, and maintenance requirements. But for the F-22, these compromises are worth it. The jet can slip past enemy radar, position itself for an attack, and leave before anyone even knows it was there. So, can the F-22 really stay invisible from radar? The short answer, sometimes. All these features shrink its radar signature, but invisible isn't quite the right word. Radars are evolving, and the Raptor isn't completely undetectable. Radars work at 3 levels: detection, tracking, and targeting. Spotting a faint blip is detection. Following it, that's tracking. Locking a missile on it, targeting. The F-22 is built to make radars struggle past the first level. Even if a radar picks up a blip, guiding a missile to it is extremely difficult. Some systems push the limits of stealth. Long-wave radars can spot the jet from a distance, though they can't give an exact location. Passive detection systems sense subtle environmental disturbances, heat, electronics, or even the way air moves around the jet. Stealth is optimized for high-frequency radars like X-band, the ones most relevant in combat. Other factors matter too. Flying straight at a radar gives the F-22 its best stealth. From the sides or rear, it reflects more. Opening weapon bays or carrying external tanks increases visibility. Open source estimates compare its radar signature to a marble or bumblebee, tiny enough to hide in plain sight. Bottom line, stealth doesn't make the F-22 invisible, but it buys precious seconds, enough for pilots to approach, strike, and vanish before the enemy even knows it's there. And while the world struggles to see it, the F-22 counters with one of the most advanced radars in the world, letting it see and strike first, giving it a clear edge in the high-tech game of hide-and-seek. While everyone is struggling to spot the F-22, the jet isn't just hiding, it's also watching. At the heart of this is its ANAPG-77 radar, one of the most advanced fighter jet radars ever built. Think of it as the F-22's supervision, letting pilots see further, faster, and without giving themselves away. This radar isn't like old-school flashlight radars with powerful beams that shout and reveal your position. Instead, the APG-77 uses low probability of intercept, or LPI. In simple terms, it whispers instead of shouting. With over 2,000 tiny transmitter and receiver modules, the radar can track more than 100 targets at once, monitor them from over 200 kilometers away, and even guide missiles without lighting up like a beacon. On top of that, it can jam enemy electronics and securely share voice and data with other aircraft, basically seeing everything while staying hidden. But spotting a threat isn't enough. The F-22 also carries a radar warning receiver and a missile launch detector. If an enemy locks on, the jet can react instantly. Flares confuse heat-seeking missiles, and chaff, tiny reflective strips, scatters radar waves to throw off radar-guided weapons. Stealth and radar work together perfectly. The design buys precious seconds to get close, while the APG-77 lets pilots see first, plan first, and strike first, often before the enemy even knows a jet is in the sky. In other words, the F-22 doesn't just vanish, it dominates the battlefield from the shadows. The fight between stealth and radar never ends. Every time radars get smarter, jets like the F-22 evolve to stay ahead. New stealth aircraft, the F-35B-21 Raider and upcoming NGAD, continue this cat-and-mouse game. Countries like Russia, China, and Europe are investing heavily in advanced detection systems. Long-wave radars, such as Russia's nebo-m, claim they can spot the Raptor from afar. But spotting a blip isn't enough. Tracking and locking weapons is far harder. The F-22 is designed to make that next step nearly impossible. The US keeps upgrading the Raptor with improved coatings, avionics, and tactics. Stealth won't make any jet invisible forever, but for the F-22, it means staying one step ahead, seeing first, striking first, and vanishing before the enemy even knows it was there. The radar versus stealth battle is still being written, but the Raptor story began decades ago in the final days of the Cold War. The US realized its aging fighters might not stand a chance against advanced Soviet jets and radar systems. The Air Force needed more than just speed or agility. It needed a jet that could outsmart enemy radar and dominate the skies. That need led to the Advanced Tactical Fighter Program, a high-stakes search for a next-generation aircraft. After years of competition, Lockheed Martin's YF-22 prototype was chosen, and by September 1997, the first F-22 took to the skies. It officially entered service in 2005, instantly setting a new standard for fighter jets worldwide. The F-22 came with a staggering price tag, so high that production was capped at just 187 jets, making it one of the rarest fighters ever built. Despite the cost, it quickly earned a reputation as America's stealthiest fighter. A machine built for speed, agility, advanced avionics, but above all to tilt the odds of every battle in America's favor. From its Cold War beginnings to today's evolving battlefield, the F-22 remains a symbol of stealth and dominance. Fear built them. Threats defined them. Fighter jets are machines designed to outrun any enemy they face. Every few decades, America has built a new generation of fighters. Each new generation made the jets stealthier and was a response to enemies that were becoming deadlier. The American fleet first started with the straight-winged Sabre. Now it flies the F-35. Together, these jets chart the path of American air power. The jet age began in 1945. The first generation of American fighters arrived in the final days of World War II, and carried into the Korean War in the mid-1950s. Their defining trait was simple. They introduced jet propulsion into combat aircraft. Propellers were gone, replaced by turbojet engines that could push aircrafts beyond 500 miles per hour. Designs typically had straight or slightly swept wings, basic turbojet engines and cannons or machine guns as their main weapons. Avionics were limited and combat resembled World War II, except it was shorter and more demanding. The F-80 Shooting Star was America's first operational jet, but the F-86 Sabre became the icon. With swept wings, it solved one of aviation's biggest problems: shockwaves forming near the speed of sound that caused instability. By sweeping the wings, engineers delayed those shockwaves, giving pilots control near Mach 1. In Korea, the Sabre fought the Soviet-built MiG-15. These were the first large-scale jet battles. Reaction times shrank to seconds, and design mattered more than ever. The Sabre's gun sights and wing design gave it the edge, but even then, fights were brutal and costly. The first generation proved jets were the future, but they also revealed limits. Engines broke down quickly, fuel vanished fast. In fact, even altitude performance was poor. Straight-wing designs struggled at transonic speeds, and these jets lacked the climb and speed to intercept nuclear bombers. To defend against those threats, America needed fighters that could go supersonic. The second generation was born in the Cold War between 1955 and 1965. America feared Soviet nuclear bombers, and fighters had to be able to climb high and strike fast before they reached U.S. cities. The hallmark of this generation was supersonic flight. Jets introduced afterburners, which injected fuel into the exhaust for bursts of thrust. They were fuel-hungry and short-lived, but they allowed fighters to pass Mach 1 with ease. Aircraft also featured delta, or highly swept wings, designed for stability at high speeds. Their weapons shifted from guns to guided air-to-air missiles. Designers believed the age of the cannon was over. Representative jets included the F-100 Super Sabre, America's first supersonic fighter, the F-104 Starfighter, capable of Mach 2 but dangerously unstable, and the F-106 Delta Dart, an interceptor optimized for long-range missiles and radar. Second-generation fighters had one mission: intercept bombers. They were built to fly fast, climb high, and shoot from a distance. Dogfighting and agility were afterthoughts, but that philosophy was a gamble. These aircraft burned through fuel and had poor low-speed handling. They were nearly helpless in close combat. They represented the belief that speed and missiles could replace maneuverability and guns. Second-generation fighters abandoned the gun completely. Engineers believed missiles had replaced it forever. But what happens when the future of air combat turns out to still need the oldest weapon of all? Drop your guesses in the comments and we'll answer this question at the end. Third-generation fighters emerged around 1965 and ran until 1975. They came with improved missiles, radars, and multi-role flexibility, but combat exposed the flaws of missile-only designs. Typical characteristics included better radars, all-weather capability, and multi-role performance. They carried heat-seeking aim, 9 Sidewinders, radar-guided aim, 7 Sparrows, and bombs for strike missions. Early jets of this era still lacked cannons, but the war changed that quickly. The F-4 Phantom II symbolized this generation. It could fly at Mach 2, carry missiles and bombs, and serve as both a fighter and bomber. But its original design omitted a gun. Military planners assumed missiles had made cannons obsolete. In Vietnam, reality hit. Missile hit rates were often under 15%. Pilots found themselves in close-range dogfights against MiG-17s and MiG-21s, where missiles missed and no gun meant death. Later, Phantoms were retrofitted with 20mm Vulcan cannons. Another lesson came from maneuverability. The Phantom was powerful but heavy. Against nimble MiGs, its lack of agility was a liability. This forced the Navy to create Top Gun, a training school that emphasized dogfighting skill and energy management, which were concepts tied directly to aircraft design. Third-generation fighters proved the need for balance and also rediscovered the importance of agility in guns. The failures of Vietnam taught engineers that the next generation had to combine agility and advanced electronics. The fourth generation, entering service in the mid-1970s up until 2000, brought fighters that were multi-role and packed with electronics. They were built not just for air-to-air combat, but also for precision ground attack. Their defining traits included high thrust-to-weight ratios, fly-by-wire controls, and look-down, shoot-down radars. They could carry short and medium-range missiles like the improved Sidewinder and Sparrow, as well as precision-guided bombs. The introduction of digital avionics made them adaptable across missions. Representative examples highlighted different philosophies. The F-14 Tomcat was built for fleet defense, with variable sweep wings and long-range Phoenix missiles. The F-15 Eagle chased absolute air superiority, combining powerful engines with advanced radar to dominate the skies. The F-16 Fighting Falcon prioritized agility, using fly-by-wire to achieve maneuvers no manual system could handle. The F/A-18 Hornet emphasized versatility, able to fight in the air or strike ground targets from carriers. Fourth-generation fighters saw combat in the Gulf War, where F-15s swept Iraqi fighters from the skies and F-16s and F/A-18s struck ground targets. They proved that agility and advanced avionics were the formula for dominance, but radar and missile systems were advancing rapidly. Even the most agile jets could be tracked and targeted. Fourth-generation fighters were powerful, but they were still visible. The solution for the next generation would be to disappear. The fifth generation arrived in the early 2000s. These fighters were defined by advanced sensors and networked warfare. Stealth came from radar-absorbing shapes and coatings, internal weapons bays, and carefully shielded engine inlets. Weapons like AIM-120 AMRAAM and guided bombs were carried inside to keep radar signatures low. The F-22 Raptor embodied the philosophy. Its angled surfaces scattered radar, its engines provided supercruise without afterburners, and thrust vectoring gave unmatched agility. In training, it achieved kill ratios of 20-1. The F-35 Lightning II followed, designed as a multi-role stealth fighter for all branches of the U.S. military. Its hallmark was sensor fusion, radar, cameras, and even infrared combined into one picture projected in the pilot's helmet. The F-35 turned the pilot into a battlefield manager, directing older jets and ground forces while remaining invisible. Fifth-generation fighters represented a shift. They were not just aircraft, but information hubs. Stealth made them hard to detect. Sensors made them nearly impossible to surprise. Networking made them leaders in the air. But stealth came with cost. These fighters were expensive to build and maintain, limiting how many could be produced. The question now was how to evolve beyond stealth alone. The sixth generation is being designed now, with the first aircraft expected in the 2030s. Programs like Next Generation Air Dominance NGAD aim to push air combat into a new era. Projected traits include adaptive cycle engines that switch between efficiency and power mid-flight, AI co-pilots to process data, or fly unmanned and loyal wingman drones that accompany manned fighters. These drones could carry weapons and absorb enemy fire. They are even made with the thought to scout ahead. Weapons may include directed energy systems, such as lasers to shoot down incoming missiles, alongside hypersonic missiles for offense. Designs often showed tailless blended-wing airframes with even greater stealth than today's F-35. But unlike the fifth generation, stealth will not be enough. Modern radars are already improving at spotting stealth aircraft. Sixth-generation fighters are being designed to survive in heavily defended airspace by combining stealth, speed, drones, and electronic warfare into one system. They represent not just a new aircraft, but a new way of fighting, a partnership between manned jets with unmanned drones and artificial intelligence. So, did fighters even need guns? Vietnam proved the gun was not dead. The Phantom II had to be retrofitted with a cannon, and Top Gun was founded to retrain pilots in close combat. Every generation since has carried both guns and missiles in an effort to remain multi-role and prepared for all types of combat. Fighter jets are the story of adaptation. They are machines born from necessity and rebuilt for survival in the skies. If you enjoyed this breakdown, like, share, and subscribe for more deep dives into the machines that shaped history.